Dear viewers, today I am going to show you the SiC MOSFET based 1 kilowatt bidirectional DC-DC converter developed by National Infotech. In this video, I have explained the buck converter. Okay, so this is the setup. Input supply is connected to the auto transformer, and the output of the auto transformer is connected to the rectifier, and the output of the rectifier is connected to the input of the buck converter. So this is the input of buck converter, and here is the load. So load is connected to the so this two terminal. Okay, so load is connected here. So load here, you can see the load is connected. Okay, and this meter shows the output voltage, output current, input voltage and input current. Okay, and this is the controller. Okay, so you can see here is the BDC with buck converter mode, and duty ratio is 50. So now you can see here schematics. So you can see when you are working with the buck converter, so input is here. Okay, so input of buck converter, and at the time of buck converter, this switch G1 Q1 switch Q1 is working. Okay, so you can apply the gate pulses to the G1. Okay, PWM pulses to the G1, and you can apply the G2 at 5 volt. Okay, and some internal connection is there which will convert 5 volt into the ground. Okay, 0 volt. So this switch is off at the time of buck converter, and this diode is appearing. Okay, so switch, this diode D1, inductor, capacitor, and the output load. Okay, so you can see here you can apply the gate pulses to the G1. Okay, and you can apply 5 volt to the G2, and some internal circuit which converted the 5 volt into ground, and the G2 switch is turn off continuously. Okay, so, and 5 volt and ground here, and this port is for the sensor outputs. Okay, and you can see here there is some red LEDs are there. If fault occurs, then this red LED is glowing, and this reset button is here. When fault is occur, then you can turn off the supply, and you can just press the reset button, then your system is fully working. Okay, so now we will start with the system, and firstly we will increase the input voltage up to 100 volt, and at duty cycle 50, and we'll see the performance. Okay, now turn on the mains. Okay, and now turn on gate pulses, and gradually increase the duty ratio. Gradually increase the voltage. Now you can see gradually increase the input voltage, and this is the DC voltage. Okay, so 100 volt DC at 0.2 ampere input current and 100 volt input voltage, and duty ratio is 50%, so the output voltage is around 50. Okay, so you can see here 48 volt output voltage at 0.1 ampere current. Now we will gradually increase the input current. Okay, so 0.5 ampere, 1.2 ampere. Okay, now we will increase the input voltage, and see the performance of 1 kilowatt. So input voltage is 350 volt at input current is 2.8 ampere. Okay, and duty ratio is 50. So you can see here output voltage is 168 volt, and ampere is 5.19. Okay, now we'll increase the current and see the performance at 1 kilowatt. Okay, so you can see here input output current is 6.4 ampere and voltage is 167 volt. So by multiplying these two values, it's a 1 kilowatt bidirectional converter with buck mode. Okay, and the input voltage is 353 and the current is 3.7. So here input voltage is half to the output voltage. Okay, so now we will increase the duty ratio. Now we'll increase the duty ratio and duty ratio up to the 62% and see the performance. Now we'll increase the duty ratio up to 65% and see the performance. So input voltage is 163 volt, 150 volt, and current is 164 and you can see the 1 kilowatt output. Okay, so now we'll gradually decrease the duty ratio up to the 20% and see the performance. Okay, so our duty ratio is now 20%. Input voltage is 350. Okay, and well, you can see the 8 pulses. Okay, now we'll increase the load and see the performance. Okay. So 3.3 ampere, 3.03 ampere at 65. Okay, well, because here input voltage is 350 and duty ratio is 20%, so that the output voltage is 65 volt and current is 4.5 ampere. Okay, so this is the overall performance of the bidirectional DC-DC converter with buck. Okay, so thank you very much.